So today we are doing rose curves, polar equations and graphs. We're on page 12 of your notes. I'd like you to stop now and actually play with your get your calculator out, and remember you're in polar mode, and go ahead and graph these and see what you come up with. Okay, you should have gotten these. And so it gives you a pretty good idea of how all of this is going to work. So there are lots of different numbers, and what do they all mean? We're going to find out. So these are the equations for polar rose curves. You can have them symmetric, with a times r is equal to a times the sine of some coefficient times theta, or times cosine. The number of petals is dependent on the coefficient of theta. If it's odd, then there are that many petals. If it's even, there are twice that many petals. The length of each petal is whatever that coefficient, that first term is, a. And the distance between the petal points is, you just take the total distance around a circle, 2 pi, and divide it by the number of petals, so n, or 2n. Cosine always has one petal symmetric to the polar axis because the cosine of 0 equals 1, and so when you multiply times the cosine, you get something. Its sine's never going to have a petal at any of the 0 or pi angles, because the sine of 0 is 0. And so if you multiply sine of 0 times 0, you have nothing. You get r equals 0. Or if you did sine pi, that's also equal to 0. So it cannot possibly have a petal on the theta equals pi over 2 axis. Sine is symmetric with respect to the theta equals pi over 2 axis. It's got the symmetry. It's cosine symmetric with respect to the polar axis. Okay. And then we go to the next page, page 13, and we're going to actually draw some of these things. We're just going to look at them first, see some examples. This 3 is symmetric with cosine is always going to have a petal on the polar axis. And here's a sine one with 4, coefficient of 4, so it's got 8 petals. This one's had 3, and with 3 petals, so the odd number is always going to have the same number of petals. Okay, let's do one. So we've got r is equal to 4 times the sine of 2 theta. The number of petals are going to be 4. The length of each is 4, because 2 times theta for the number of petals, and the length is this number right here. Okay, so the distance between each of the petals is going to be 2 pi over 4, which of course is pi over 2, 90 degrees. One petal point will be at 4, because you're going to have a radius of 4. And pi over 4 will be, since you're dividing it into 4 pieces, pi over 4 is one angle, and the symmetry is going to be with the theta equals pi over 2 axis. Okay, so when you're graphing, your coefficient is 2, so we're going to have a column of theta, which is what you're going to actually graph, and we're going to have a radius, which you're going to actually graph. So these are the 2 columns you're actually going to use. But we're going to calculate based upon 4 times the sine of some number 2 theta in this case. So we're going to pick out 2 thetas that are convenient. So 0 is 2 theta, if that's the case. We've got that. So it's 4 times 0 is equal to 0. So that's the first point. 0, 0. And then we pick the point pi over 6 because we can find the cosine, the sine of that. And therefore we'd be graphing pi over 12. And then the sine is equal to, I'm going to write this here so I keep forgetting it, 2 times theta, 4 times the sine of 2 theta. So we take 4 times 1/2, which is the sine of 2 theta pi over 6, which is 2. And so we've got a radius of 2, and this time the angle is pi over 12, so that's about halfway here, right here. And we can reflect that point right over here. And so we'll do that in just a second when I get a better feel for where that will be. The next 2 theta we'll choose is pi over 2, which gives us a center 2 theta of pi over 4. So we take 4 times the sine of pi over 2, which is 1, and it gives us 4. So 1, 2, 3, 4. So really you've got what you need here for the angles, for the symmetry around there. And so we've got enough to graph the first petal. And then we can reflect each one of these. So we're going to come right over here. We're going to count around this circle, pi over 4, and we're going to add pi over 2 to that, so that'll give us 3 pi over 4 for the next petal tip. And then we're going down to 5 pi over 4. 1, 2, 3, 4. And then 7 pi over 4 for the other petal tip. And then we can, again, draw your petals. So we just go ahead and one, 2, 3, 4. Okay, so there's the first one. You don't need any more than this. You can reflect everything. Okay, we're going to graph this using your calculator. We want to show off the restricted domain. And so get your calculator and go ahead and type in your graph. And I'm going to type in, this is 4 sine 2 theta. So I'll just zoom 7. Make sure you're in polar mode. Okay. And we want to do the restricted part. So I'm going to go ahead and I'm going to change this to a dark line so that it'll make it a little bit. I'm going to press enter a couple of times to get a heavy line. That one looks good. So I'll go ahead and graph that now. And I forgot to put the restrictions on it, so let's come back and put the restrictions. So we're going to put a division sign. It's like wondering why did it do that whole thing. So divided by with sign and then parentheses, and then we're going to type in theta has to be greater than. We're going to use second math, greater than or equal to. It's number 4. And we want to be greater than or equal to 0. And we want to include the and. So go second math again, over to the logic menu and press enter. And then again we want theta to be less than or equal to, so second math, number 4. We want it, I've got the wrong one, did number second math, I want 6. Less than or equal to pi. And then close your parentheses. Now we'll try it. Okay, so that's the restricted domain. So it's really just those two petals. And we will just highlight those. And here's the green ones in orange. I thought I was doing. Oh, lovely. That's a little better. Okay. All right, so just a quick reminder how to type in that. You type the equation into your calculator, into your Y1, and then type in theta greater than or equal to 0, and command theta less than or equal to pi. And you can find this under second math. You can find the and under second math logic menu. Okay, that should get you what you need now. So next page. Okay, so 5 times cosine of 3 theta is going to have 3 petals, which matches that number, 3. The length will be this number, which is 5. And the distance between the petals will be 2 pi divided by 3, which is 120 degrees, if it's in degrees, but that's, just add 2 pi over 3 probably. 1 petal point. Since it's cosine, it was going to be on the polar axis, so 1, 2, 3, 4, 5 for sure. And that point will be 5, 0. And the symmetry is on the polar axis. So we've got that. Okay, I'm going to pick in some convenient numbers again, as we did before. So we 0. And you can verify these for yourself at some point. Pi over 3, pi over 9. Don't really need a lot of points here because we know how the symmetry is going to be working. This is approximately equal to 2.5. And I want to include one more point, pi over 2 and pi over 6 for the theta that I'm actually going to graph. And of course the cosine of pi over 2 is 0. And so 5 times that is also 0. So we're going to graph those points. 0, 5, and then pi over 9, which is just a little tiny bit more than that. And the radius is 2.5 of that. So 1, 2, a little bit more than that. And pi over 2 and 0. Okay, so we've actually got that, and all we have to do is reflect everything. Okay, so there's 1. And we're going to be adding 2 pi over 3. So here's the next one. 1, 2, 3, 4, 5. And then add 2 more pi over 3. That gives us 4 pi over 3. So here's the other petal point. And so basically you've got this and this. And after you've shown one set of exact points, you don't have to do anything but the tips. Get the tips on there. That'll be great. Okay, now let's do the next one. 3 times sine 5 theta. So there's going to be 5 petals, and each one will be 3. The distance between the petal points, of course, will be 2 pi divided by 5, which gets to be a little bit of a challenging number. 1 petal point will have a radius of 3, and the symmetry will be around the line theta equals pi over 2, also known as the y-axis. So we're going to pick some convenient points. We don't need a lot. So picking 0. So 3 times the sine of 0, of course, is 0. So there's our first point. And then we're going to pick pi over 6, since we can easily take the sine of pi over 6. that gives us the inconvenient theta to graph of pi over 30. So 3 times that is 3/2, or about 1.5. So pi over 30 and 1.5 is really not much. So about right here. It gives us a middle point. And of course we can reflect that right over there. And then let's go ahead and pi over 2. I think I reflected on the wrong direction. Pi over 2, so we'll just ignore that 1 point I made. Pi over 2, and we'll divide that by 5, so we get pi over 10. So we end up with 3 times the sine pi over 2, which is 3. And so that's the radius at pi over 2. I'm graphing that line pi over the point over 2. Zero. So we pi over 30 and 3.5. So pi over 2 and pi over 10. Pi over 10 is the angle, and it is really tiny. So it's about right here, and the radius is 3. So 1, 2, 3. And we'll just put it right about here. And then we're going to reflect that properly over here. So about there. So there it is, the point, tip. And we're going to show the addition. So we'll start out at pi over 10. That's where we're ending here. So pi over 10, which is what that angle is, plus 2 pi over 5 gives us pi over 2. For our next pedal point, and that's at radius of 3. And then we'll have a next pedal point. We're going to add pi over 2 plus 2 pi over 5, and that will give us, when you figure it all out, that's 5 pi plus 2 times 2 is 4 pi over 10. That's 9 pi over 10. So it's almost 1 whole pi. Not quite. So it goes a little bit, but the radius is still 3. 1, 2, 3. So we're almost 2 pi. And then we keep going. 9 pi over 10 plus 2 pi. So that's 9 pi plus 4 pi over 10. That's 13 pi over 10, which is a little bit more than 3 pi, 1 whole pi. So it's a little before, I guess, before 4 pi over 3. So 1, 2, 3, about right here. Then we have one more pedal, and it 13 pi over 10 plus 4 pi over 10. So that's 17 pi over 10. And we get one more pedal, so one, a little bit more than, or just before you get to 5 pi over 3. So 1, 2, 3. All right, we can go ahead and draw our pedals. And again, if you get one set of points for the edges, that'll be good. Okay. Again, check your calculator, and let's do the restriction on that. You'll find clear. And we're taking 3 times the sine of 5. And we want between pi over 2, so I'm going to change this between, theta is going to be between, so pi, and I'm going to insert divided by 2. and 3 pi over 2. So I'm going to insert 3 pi, and then insert again over here, divided by 2. And I also have the 3 times the sine of 5 pi. I just want to see what it looks like. The sine of 5 pi, 5 theta rather. Okay, so that should give us both of them. Okay, and I needed to put parentheses around everything. Insert parentheses. And close. Then we have to close the parentheses. I did not close the parentheses. And so I'm going to come back here and now I should graph it. Okay. I'm not going to worry with that now. I've got too many parentheses here. Delete. And graph. Okay. I'm not going to mess with it anymore. But be careful with your restrictions as you're doing it. Okay. And we're going to go one more page, I think. 15, page 15. And starting on some lemniscates. We can do this one real quickly. I'm not going to draw all of it, but we'll just get a few of the petals, or at least, yeah, a couple of the petals drawn. Number of petals, there's going to be 4 times 2, so 8, and the length of each is 6. So the distance between the petals, you're going to take 2 pi divided by 6, which will give us almost 2 pi divided by 8, which gives pi over 4 between each of the petals. And so one petal point will have a radius of 6 with the symmetry for the polar axis. Don't want to spend too much time, but we're going to pick 4 theta and pick 0, of course, to start with. And we get 6 times the cosine of 0, which is 1. So we have 0 and 6. 1, 2, 6. And then pick some, we need some bit of a few side points, so pi over 3. It's a convenient one, then pi over 12. So then we take 6 times 1/2, which is 3. And all I did was the math. R is equal to 6 times the cosine of 4 theta. Okay, so we have pi over 12, which is not a big angle, and 3. So 1, 2, 3. And we are on either side of this. So I'll just go ahead and draw the first petal. And we want to add pi over 4 to that, so we'll come over here and just draw another petal. You know, just a little bit onto the side of adding pi over 4. And you're going to go pi over 4 all the way around. And you will end up with the 8 petals. So you go ahead and sketch those in there. And check your calculator also. Be sure to do your restrictions properly. Now we're going to go on to lemniscates. They're basically figure 8s. Come in 2 equations. You can recognize that a lemniscate when it has an r squared. R squared is going to equal whatever that a value is, and it's squared. And it'll have symmetry with respect to the x-axis and the y-axis. and the pole, the polar, just the pole. And when it's sine, it'll be symmetric with the pole only. So basically with the origin. So A is the length of, and that's of course the square root of this number. A is the length of one loop, and which is half of the figure 8. So this is one loop. So square root, so that would be 9. So the square root of the 9 is 3. Here's the same with the square root of 4 is 2. So that's, and it's symmetric with the polar axis, with the y equals 2 axis, and it's symmetric with the pole. This one's only symmetric with the pole. It seems to be asymptotic, which uses the axes as asymptotes, really. Okay, now let's graph some. Okay, so we can see r squared is equal to 25 times sine of 2 theta. We know that it's a sine, so it'll be symmetric with the pole, which again is the origin in the rectangular coordinate system. And the length of one loop is going to be the square root of 25, which is 5. Okay, and then we've got 2 theta. We're going to pick convenient numbers again. R squared, I'm just going to rewrite that equation. 25 sine 2 theta. And then we just take the square root of that to get r. So r squared equals 0 because the sine of 0 is 0. And so 0 is the r. So we have a point at 0, 0. And if we pick pi over 6 as our point, we'll have pi over 12 as the theta. R squared will equal 25 times the sine of pi over 6, which is 1/2. So it's about 25 halves. It is 25 halves. And theta, or the radius, will equal the square root of that. So it's 5, and it rationalizes as well, square root of 2 over 2. Plus or minus that, actually. So that gives us a couple of different totals. So that's like 2.5 times 1 1/4. So it's pi over 4 and pi over 12 is one of the points. And the radius is going to be a little more than, so pi over 12. Let's go ahead and just do pi over 4. I don't think we need to calculate all that stuff. So pi over 2, pi over 4. If you get the tips for the lemniscate die, I will be most happy with that. R squared will equal 25. You don't have to do a lot of this math. Is not needed. I mean, for exactness, you've got a calculator. Sine of pi over 2. And that is 25 times 1. So it's 25. And r squared will equal 25, and r equals plus or minus 5. So that's the radius is plus or minus 5. So at pi over 4, the angle is 1, 2, 3, 4, 5. This is a positive one going towards the pi over 4, and we're going to go back to the origin and go negative 1, 2, 3, 4, 5. So there's this, and they're pretty close to being kind of interesting to watch this one graph on the calculator. I invite you to do that. Okay, so that's one that is symmetric with the pole. Now the r squared is equal to 16 times the cosine of 2 theta. Symmetry is the pole and polar axis, as well as the y-axis, which is theta equals pi over 2. It's all three of those will be symmetric with those. And the length of one loop is going to be 4. Now, we've got, because we're going to go ahead and draw some, like some asymptotes, kind of, like since we're going to be doing this, and we're going to draw those, break that, since it's 2 theta, we are going to break it into 4 regions, really. So 3 pi over 4. And these are just guidelines to help us graph this. And so we first find 0 and 0, and we've got r squared is equal to 16 times the cosine of 0. 0, which is 1. So r is equal to 4. Actually, r is equal to plus or minus 4. So we'll take 4, 1, 2, 3, 4. Get on the polar axis, 1, 2, 3, 4. Okay. And the negative radius, 1, 2, 3, 4. And we're going to use these as, again, kind of like asymptotes. So we'll go. If you watch these being graphed on the calculator, you can kind of see what I'm talking about there. Okay. That is it. So you have homework, and if you have questions, please email me. I will see you next week later, or maybe on Friday, or if I don't see you again, have a wonderful, wonderful holiday. Bye.